for this problem, it says what are the zeros of this equation? It says graph. Now, we see this equation's in factored form. Let's work backwards for a second and write the original equation. So I could multiply x times x minus 4, so I would get x squared. That's not anything there. So x squared minus 4x, and then I could distribute that to x plus 3. I'm going to come over here and make a little box. X 3. Multiply inside, add on out. So we get x cubed, we get minus 4x squared, we get 3x squared, we get negative 12x. I can add everything on the inside, so I know it's y equals x cubed minus x squared minus 12x. So we see that it's degree 3. So I like to first think, okay, what will this graph look like? Looks something like that, right? Now, let's think about in behavior for a sec. So the leading coefficient is a 1. So if the leading coefficient is a 1, on the right-hand side, we're going to be pointing up. And if the degree is odd, right, our arrows are going to be in opposite directions. So on the left, our graph will be heading down. So that's one thing to remember. That's really why I put in standard form to see that. Now, if you see something in factored form, you can quickly find the zeros, which are the x-intercepts. So we'll set each factor equal to 0 and solve. So we'll have an x-intercept at 0, which you see here. You have an x-intercept at 4, which you see here. And we have an x-intercept at negative 3, which we see here. Now, if I know on the far right side my graph is going up, I'm going to do some kind of up arrow, and on the far left it's heading down. Now I know it's going to go like this, right? It's going to cross. I right now don't know how high it's going to go, but it's going to then come down. I don't know how low, but then it has to go up towards infinity. So I know that little bit. Now let me figure out what's going on in between the intercepts. So I'm going to plug in a few values. So let me I'll plug in negative 2. Let's see what happens when we plug in negative 2. So f of negative 2 is equal to negative 2 times negative 2 minus 4, negative 2 plus 3. So we get negative 2 times negative 6 times 1. So we get negative 12. Oh, no, it's positive 12. So we have in went negative 2, out comes 12. So negative 2, we are at 12. 1, 2, 3, 4. So we'll say it's way up here. Okay, I could do some more points in between. I'm going to plug in 1. So if I plug in 1, I want to see what's going on in between these zeros. I would have 1 times 1 minus 4 times 1 plus 3. So I have 1 times negative 3 times 4. So I'd have 1 minus 12, which is, oops, no. I'd have, 1 times negative 12, which would get me negative 12. So the ordered pair here is 1, negative 12. So that's going to be somewhere way down here, right? So that's a rough sketch of my graph, and I use zeros, and I can plug in points in between our zeros and use our in behavior to draw a sketch. Let's go on to the next question. How does a multiple 0 affect the graph of a function? Well, let's look at the last graph we just did. We saw that it was x minus 4, x plus 3. equals x, x minus 4, and x plus 3. Now at 0, just going to undo that. If this was the x-axis, we had a dot at -3, a dot at 0, and a dot at 4. And because we talked about in behavior, we knew over here it was heading up, down. We plotted a point between our zeros, and we got a sketch like that. Now notice, for each factor, you only see it one time, so the degree is 1. Okay? When the degree of a factor is odd, you're going to cross through the x-intercept. So if this is an x-intercept, you're going to cross through. If this is an x-intercept, you could cross through that way when the power is odd. If you had an equation like this, y equals quantity x minus 1 squared. Okay, well, if you set this equal to 0 and solve, you take the square root of both sides, plus or minus. So x minus 1 equals plus or minus 0, which is 0. Add 1, x equals 1. Now, if you do a dot here on 1, if you plug in values on either side to get a sketch, let's see what we get. So if we plug in 0, we get 0 minus 1 squared, which is -1 squared, which is 1. So in went 0, out comes 1. If we plug in 2, 2 minus 1 squared is 1 squared, which is 1, so 2 comma 1. And we know that it's quadratic, it's parabola. If your expression has an even power, the factor happens an even amount of times, then you're going to be tangent at that spot. Okay? So that's what we mean by multiplicity, or multiple zeros. The power, how many times does it happen? Once. 2, x minus 1, x minus 1. So when it happens an even amount of times, you're going to be tangent. And you could have tangent like this, or on top. So either all above or all below. Next page. What are all the real and complex zeros of the polynomial function? Okay, well, if you know the power is 3, if you know the degree is 3, you should have 3x equals, like the last one, some of these could repeat, or they don't have to, but when we solve, we want to have x equals, x equals, x equals, because the power is 3. So power 3, so we're going to write x equals 3 times. It might help from avoiding mistake. So let's look over here. We only see it touch x-axis here at 2, right? So we know if we have 3 x equals, we know we see it touch at 2, so x equals 2, the x value is 2. Now we don't see it touch anywhere else, so that means that we have complex zeros, so these have to do with complex zeros. Imaginary, right? We know that we have 2 complex because if it's degree 3 and it passes through here once, this spot, the power of the quantity x minus 2 has to be odd. So we know it happens one time based on this function being degree 3. What are all of them? So one thing we can do is synthetic division to take out this one factor, right, where we had that 0, and continue factoring or breaking down. So if we know that the x value is 2, x equals 2, it should go in evenly. We shouldn't have a remainder. So over here we have 1x cubed, 1x squared, minus 3x, minus 6. So we're going to go in front of degree 3 is a 1, in front of degree 2 is a 1, in front of x is a negative 3, constant is a 6. So 1 drops down, we have 1, we multiply 1 times 2, 2 plus 1 is 3, 3 times 2 is 6, 6 minus 3 is 3, 3 times 2 is 12, or no, just kidding, 6, and this was supposed to be negative 6, right? We add, we get 0. Now I need to go back and check because there shouldn't be a remainder because x equals 2 is a 0. It does go in evenly. Now we know that when we write our answer, we drop a degree, so we have 1x squared plus 3x plus 3. So we're now going to set this equal to 0 to solve and find the remaining zeros. Let's see if we can factor. Can we factor? Is there a quantity that multiplies to 3 that adds to 3? 1 and 3? No. So we can't factor. We can use the quadratic formula though. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So we have negative 3 plus or minus square root of 9 minus 12 over 2, which is equal to negative 3 plus or minus square root of negative 4 over 2. Negative comes out as an I, square root of 4 is 2. So we have negative 3 plus or minus 2I over 2. So we have our two complex values. If we set, I'm going to erase some of this over here. If we said, okay, these are our values, x equals negative 3 plus 2I over 2, x equals negative 3 minus 2I over 2. On top, we can write this as negative 3 halves plus 1I. On bottom, we can write this as negative 3 halves minus 1I. So now we have our 3 zeros. So we have x equals 2, check. We have x equals negative 3 halves plus 1I or I, check. X equals negative 3 halves minus I, check.